I would like to talk a little bit about fractures. So if you are doing a rigid body simulation, you'll need to fracture your geometry if you want it to break. So I'm going to just put down a geometry node, then dive inside. And in here, I'm going to put down a box. I'm going to take its size up in X and Z. Maybe take it a little bit down in Y. And now if you are using a RBD material fracture, I move the blue flag. So this piece will be fractured twice. First, it will be fractured into 5 bits, according to this. And then it will be fractured again, where each bit will be fractured into 5 pieces. So we probably should have 25 pieces. And I'm going to put down an exploded view because I want to see inside the fractures. Here. You can explode the geometry out. And these fractures are very even and very flat. So in the RBD material node, I'm going to go into detail. And notice this value here. If you have something big, you should take this value up, because this is the distance between the points that will be added. So now it's 5 centimeters. So if you toggle edge detail, you can see that you have a lot more geometry. So the distance between the points here are around 0.05 meters or 5 centimeters. Let's say in my simulation, I'm going to be looking at this from afar, so I might not need this much detail. So first I'm going to go up here and take the detail size up. Maybe we can try 0.2. And then we have something like this. And the next thing to think about is the noise element size. But it's kind of hard to see, so I'm going to take the noise height up first. This is the amplitude. So let's try 0.5. So the distance between here and here should be around 20 centimeters. And as you can see, the distance between the waves and the noise patterns are the same as the distance between the points inside. So to get more interesting fracture, let's increase the element size. I'm going to say 0.5. Maybe a bit more, 1 meter, something like this. And then you can increase the height. So just know if you increase some of these values too much, you will break the node. The edge detail is the detail at the edge. So this line here, how detailed is it? And what type of detail does it have? The interior details is the details inside. So I'm going to go upstairs, I'm going to make this box a little thicker. And for this we can even turn off the edge detail. And let's look at the interior details. The interior detail has nothing to do with the edge, it only has to do with the interior. And in this case it asks for frequency. The frequency is the opposite of the element size, or 1 divided by the element size. So the higher the frequency, the more waves you'll get. So I want to take this value down, so I'm going to try 0.1. And I'm just going to copy this parameter, and into both of the other ones, I'm going to do paste relative reference. And here again, paste relative reference. Let's see what we got. And then we can increase the amplitude. And you can see now we have these very big waves. Let's increase the frequency. Maybe something like this. Something like this maybe, depending on your material. You might also want to take the detail size a bit down, but always think about how far away your camera is. So maybe something like this. So if you go back to a lower frequency, 0.1, you can see the difference between this one. And then if we double it, you have some more waves. And if we go all the way up to 2.5 like the default, we have something like this, which might be too high for us. Well, we'll have to take the amplitude down. But I think I'm gonna go with just frequency of 1. Something like this. And now you can look at both the edge detail and the interior together. And you got something like this. So I think for the edge detail, I want the noise element size to be bigger. I want bigger waves. Yeah, maybe something like this. Then I'm gonna go back to the box, take it down to, what did we have it as? 0.5. Something like this. And since we are here and we have prepared our fracture, let's just do a drop test on it. So I'm gonna go back to my RGB material fracture. But before that, I'm gonna go up to the box and I'm gonna move it up a little bit, see where it is in relation to the ground. Let's try to drop it like this, see how it looks. Another thing I like about this node is the chipping. This will create smaller chips around the bigger fracture. And these parameters will set where to chip. Let's add a little bit more chipping. Let's try 0.8. Wait a little bit, so we have a few more chips. Okay, let's put down an RPD configure. And let's connect these 3 and move the blue flag. And it's erroring. There's no reason why it's erroring. In here you set the parameters for the simulation objects, and these will be written out to attributes that then the solver will read. And if you go here into proxy geometry, you will see it has a density and how much it bounce, and these are basically the parameters down here. I'm going to say it's concrete. The density of concrete can be around 2,400 kilograms per square meter. So set the density, and then let's put down a RPD bullet solver. And let's add a ground plane, and let's drop this guy to the ground. I'm going to toggle real time. And let's bring it up higher. And this might still not be high enough resolution for you, so you might have to go to the detail tab of your RPD material fracture and take this detail size down. But maybe if you're simulating from out here, you can't really see it. Or maybe there is smoke in front, or whatever it is. I'm going to put down a camera, and then I'm going to go into Solaris and just do a quick render to see how it looks. So first of all, I'm going to take my render geometry. I'm going to see what attributes I have. I'm good with these attributes, all good. And then I'm just going to put down an output. So this is the node that will be rendered. Let's go to Solaris. In here, I'm going to do a scene import. And actually back on object level, I'm going to put down a skylight. Just because I like how it looks. I'm going to rotate the lights a little bit. No, let's rotate it around Y instead. Let's go back into Solaris, Stage, and let's import all of the stuff. So I'm going to force all of the objects. Camera, I'm going to hold down Control, Dio, Skylight, Sunlight, Accept Pattern. Everything is in here. I'm going to set the view to camera, my camera, and I want to hide the light. So I'm going to untoggle Display Light Gates. Now I'm going to change the view to a render view. So Karma CPU, since I don't really have the graphic cards for XPU. And now I feel like we have some depth of field there. So I'm just going to pin the view, go to object level, go to my camera. Let's unpin the view a little bit. I think we can just like drag this guy out to be like this. Let's see how this looks. So let's go back into stage and let's see if it's in focus. Yeah, looks okay. Let's give it a material. Move the blue flag. I'm gonna assign to geometry. And in there, I'm gonna choose Geo1. Okay, and dive inside. Open up the material palette. And since I didn't set up any UVs, I'm just gonna use a principal shader. Take down the reflection. Maybe increase the roughness. I don't know what the IOR of concrete is, so let's keep it like that. And then in displacement, let's just give it some noise displacement. If you have any questions or if you're curious about something, put it in the comments and I will make a video about it.